time, I think it's very important, exists everywhere and exists all the time now, always working. Okay? So, as you know, that rotation of the Earth gave day and night. And similar to that kind of cycles, we have their own system to be oscillating in my body. And our body is very tiny, but it's independent. They have the oscillating systems. And since there's all the things, there is since very Earth cycle and our cycle very similar, they are synchronized. What is the synchronizer? Synchronizer is a dark light cycle. Okay? So light is not an inducer of the rhythm, but only a synchronizer. This is the concept. Our body, as you know, it is regulated by various rhythmic materials. Its biggest thing is sleep in the night. We all experience every day. And also that many birth events or pregnant events are determined by the circadian clock. And also that several diseases like asthma or rheumatoid arthritis occur in the morning time. It's well known. And recently it's very important things, heart attack. Heart insufficiency occurred in the morning time. Those rhythms are generated by the translation feedback loop of the clock genes. So clock gene is only in a few, within a 10, okay? So only a very minute number of genes. They are transcription factors, and they are some positive element bind to the cyclic expression of clock gene, and this clock gene itself became a third negative element to minus the positive element. This is seesaw game like this. This is generation of the over. Okay. As for the hormones, it's very famous for that. There is that it's human data. It's not mine, but for example, the pituitary hormones, TSH first in the just evening time, and also the melatonin followed 3 or 4 hours later for the peaks, and also there are several 4 or 5 hours later the cortisol is up. This will generally occur, but GH is not. As you know, this is a sleep-induced, not circadian rhythm. But GH is not exceptional for that. When thinking about the response to GH-RH, this is the human data also for this. As you can clearly see, the response of GH secretion is enhanced in the nighttime, but not in the daytime. There's a clear circadian rhythm. So there is a hormonal event may have circadian rhythm. Okay? And also there was a record in such kind of rhythms in the body, in the teeth. You see, this is the animal, most strong tissue in the body. They have such kind of trunks, and also dentin exists like this. So this is a calcium attachment. So this is, we can say that all of the bodies have the rhythm in a water metabolism too. Okay. So we begin our study. For myself, I am a circuit biologist of the suprachiasmatic in the brain begins. But for this, for the very intensely worked in the field of circuit biology is the isolation of power. We fortunately isolated mammalian first period gene in 1997. And after that, many workers followed. And within several days, this kind of groups are formed. So a core group would say that they are positive factors to that PAR gene, and also the negative factors, CRY and PAR, is the main component of the core groups. But already, this is finished already about 5 years after the 1997. So it's around 2000. This scheme is already known about it. And now, since other persons are talking, but now we say, not co-oscillator, we say this is genetic oscillator. Okay? So now we say that the genetic oscillator changed the concept of the rhythms. Previously, it was said only a brain cell have the oscillatory activity, and the others follows. But this concept of circuit transition feedback loop established, we know that all the cells, 60 trillion of cells, have the rhythms. Okay? So all cells, liver cells and skin cells, all have the clocks. And SCN said, what is it doing? They synchronize and govern all these cell clock to be synchronized. This is the role of the SCN. So the biological clock is a system composed of central clock and peripheral clocks. Okay? So I will show about after cloning, we try to do about to making that PAR1 promoter oscillating thing, and due to the luciferase fusion transgenicomyces. And I found that, as you can see, at the single cell level, they have the oscillation. This is the same center of the circulating system. It seems in the dorsal to ventral, they are moving the oscillations. They are some are the morning rise, and some are the lunchtime rise, some are the evening time, but never they show the peak in the nighttime. So they are the different for the phases, but harmonized. Okay? This is the concept of the SCN they are doing about oscillations. This is the SCN. But now it is known that this is not the SCN only. Liver cell and skin cells all have this kind of strong oscillation. Okay? But modern society loses rhythms because, as you know, that the global economy distracts such kind of time scales, time, and forces 24-hour labor. So where the long workers and also the shift workers are very common now. So we can say that earth and body have the clocks, but society loses rhythm for the money, I can say. And so this is a very big study of the Japan, for the every 4 years for the Japan's national news broadcaster. They made a big survey for every 4 years. So it is a very consistent data of the, as you can see, sleepers at 10 p.m. So decreased year by year. Now 40 years before, about 60%, 70% slept at 10 o'clock, but now below the 20%. But sleeping time decreased in 40 years, about 1.5 hours. Okay? Such drastic change occurred recent years. So perhaps it changed so that the increase of new type sleep rhythm-related disorders caused by change of lifestyles. So So previously only we can say is that manic depression syndrome, or maybe the only links for the insomnia only, for the rhythm abnormality. But now we can think about the lifestyle disease, metabolic syndrome, diabetes, and hypertension, and cancer. So rhythm disorders are in the disease of our times. So, but work very since we clone the clock gene part, but rapidly many persons are very interested in this field, and we know when think about biological rhythms, its beginning and development. Recent understanding of this field is developing, okay? Since there's a lot of molecular works there. So this is the hypothesis, but we can say that external in the Earth, the external oscillator exists. They are temperatures, diets, and then cycles. So they can be the oscillator, okay? And also, perhaps, it will appear the next time, the metabolic oscillator. Because recently, as you know, that the SIRT1s in AD31 system, and also that the very astonishing finding is that the red blood cell have also the rhythm. So, peroxydiroxine story is coming. So, this is still not yet confirmed. But it is, I think it is one of the primitive oscillators exists, and there should be many is possibility. Okay? But perhaps organisms invade what I saw, that the genetic oscillator. After this kind of external oscillator and metabolic oscillator. So, genetic oscillator, we say, is a genetic oscillator composed of core clock and clock control genes. So, genetic oscillator coupled to clock control genes is very important, it's my speculation. This is a more busy slide for this. As you can say, that this kind of external oscillator to metabolic oscillator linked to the same area, to the genetic oscillator. But genetic oscillator coupled to the clock control gene, standard clock control gene. It regulates cell cycle, regulates many of the metabolism, and tuning clock itself. So this is maybe the very important for causing the diseases. So we think that, there was a key, as I said, from this scheme, that CCG, clock control gene. So most clock control genes are cell type specific, okay? The genetic oscillator coupled to CCG is very important, what I say, and also abnormal core clock will lead to the abnormal rhythm, but cell-specific abnormal clock control gene leads to disease. This is a hypothesis, but we are working in the line of this concept. First, in the presentation, I have several pieces I'll show to you. First, I show that the CCG. What is CCG? Clock control gene. I will show the example of this. CCG is SCN for sleep-waking rhythms, and CCG is the urinary bladder. This is all the physiological relevant CCG we confirm. So I will stop to you. Later, I'll talk about the disease of the cancer or hypertension. So what is the sprechocytes? They are located in the chiasma, very small nucleus. In the human, even human in a 2 millimeter, less than 2 millimeter. So it's very small nucleus. And we are isolating from this site to the gene, expressed gene, and we found we were working how to determine the cycle, behavior cycle, right? One example for this kind of works, we discovered the RG16. The RG16, I made a knockout mice. First, I'll show about compared to the previous slides, like this. It's a wild type, so dorsal to ventral exists. And also, please see, in the knockout mice, no, only a one, this is wild type, as you can see, dorsal to ventral, but knockout mice, please see it. Only one direction, okay? Only one direction, very small. This is a tiny change. It seems to have tiny change, but I think it is not. RG16, what is the substance? RG16, it is expressing the CT4. It's a morning time when we wake up, but in the night time it's nothing. It's a very clear change, specifically expressing the CN. And RG16 in the SCN show also the protein level have the rhythms, very clear rhythms of the protein levels at this. Okay. This is what is RG16? This is G protein related proteins. So RG16 is clock control gene. It is only expressed in the morning time. So the morning alarm of the RG16 exists. So RG16, what RG16 do? So it binds to the GI to inhibit the GI activity in the SCN. And so the adenylyl cyclase increase into the cell is usually blocked by the GI, but in here it is not blocked in a morning time only. So morning time, when the RG60 is expressed, adenylyl cyclase signals going to the cyclic cell body and cyclically increase, and PKA activates, and PAR1 promoter. This is the clock gene pair. PAR promoter usually cycles by the E boxes, but the Kure site also exists to change the phases for the slightly advanced phases. For this kind of mechanism occurred in a specific part of the SCN neurons. Okay? When we knock out it, first expression, usually first expression is nothing in the SCN. Okay? And only the CT0, it's when of the dawn expressed in this type of cells. Okay, cyclic AMP increases in this CT0 only. But RG16 knockout mice, nothing expressed. We measure the cyclic AMP component directly punching the cell, very small nucleus. We found that the wild type animals saw that very clear rhythm of the peak in the CT0 to 2 and drop in the night time. In the knockout mice, just knockout mice, there's no rhythm here. So this is our assumption, it will be occur. So what happened to the behavior? So RG16 knockout mice, as you can see, usual mice have the slightly shorter than the 24 hours, but RG16 knockout mice longer than 24 hours. So its elongation occurs, at least for that, because they are lazy, so it is difficult to say. So similar to the S-cyclic MP was inhibited by THFA pharmacologically implanted into the ventricles, as you can see. But also in here, elongation occurs. So it's very nearly equal phenotype. So RG16, what is doing RG16? In the SCN clock cells, G protein signaling says good morning to clock genes to wake up for the slightly, so without it, it's lazy to be slightly all the time. So next I will show the relevant things for the urinary bladder. So I'll do quickly, I don't have time. So urinary bladder also has a rhythm. As you can see here, right side, the rhythmic in the muscle here. So this is a part 2 oscillations, as you can see. And the urinary bladder, as you know, it's a very muscular organ, as you can see, that mostly 80% to 9% of muscle exists. So what is that? So as you know, that expansion and empty occurs every several hours, you know, for the urinations. But for maximum expansibility is increased, might be increased at night, because for sound sleep, we cannot, if they are not so much big, we cannot sleep. Every 2 or 5 hours we must wake up. Okay? So as the circadian clock regulates maximum expansion of the bladder, then what mechanism? This is a very wise, we collaborate with urologists in Kyoto University's medical sections, and they invented very interesting thing for the mice micturition is very minute, only 10 micrometer to 40 micrometer. So it's very interesting to know that they are moving and doing this. So the plots of the scalp on always paper is moving. Using this, we measured about it. So for this, what is the contraction of this? So the Connexin 45 plays a major role for bladder contraction. So cholinergic stimulation and Connexin 43 decreases urinary capacity, and the functional numeric acid decreases, and micturition frequency increases. For this, we verified it by the knockout mice. Connexin 43 knockout is embryonic lethal, so the heterozygotes. Please see it. So it's very big here. So contraction is inhibited, so that they have the big urination. Okay. So we do that circadian change of this kind of machine to the usual mice. As you can see, very clear rhythm. Okay. The nighttime, when they are daytime, it's nighttime for sleep. Okay, they are big, and the LD and DD, a completely dark condition, also occur this like this. And this is interesting data for the Connexin 43. Connection with all the type of rhythms. Now this is a knockout mice, nothing no reason to say. Okay, and also this is a clock gene knockout mice. So, and as you can see, the connection protein in the nighttime very high, and the expression we measure about the inside chemistry too. We do this rather smooth muscle cells with a Rushby yellow microinjection, decoupling. And decoupling, as you can see, there was circadian change of the 24 hours when they are the connections high, connection low, they are small. But when there was connection high, Rushby is big. So there was a circadian regulated. And we found that this is a new mechanism of this. I skipped most of the data, but we can say the level are dependent transcription regulations. So Connexin 43 to the SP1 side exists, and the SP1 side binds, and to the SP1 level alpha cyclically binds to this and generate the expressions. Okay, this is a new mechanism to have the clock control genes, but this is occurred, what you can see. So in the bladder small muscle cells, clock genes suppress the expression of gap junction protein in sleeping time for a good night's sleep. Okay, this is what we found with the relevancy. Next actually is the cancer, but I don't have not so much time, so that only skips the show. So as you know that this is a study of that. Many of the flight attendants and the night-shift nurses have the high index of the breast cancer, but the blind people are less incidence of breast cancers. What is the molecular mechanism? We, for the long time before, but we found that the circadian clock regulates the V1 expression. V1 is the inhibitory kinase to G2 to M. And when inhibited, the mitosis does not occur. So that's the reason why the mice have the only morning time mitosis occurred, and human, many of the mitosis occurred in the nighttime. Okay? And also, it is known that HER2 knockout might have the c-MYC is increased. It is demonstrated already. And also, recently that MOCRI and the checkpoint 1 and the ATM binding to the PAR protein occurred. So, many phases to be interacted, but not yet determined. So it's a very big problem, still remains. We don't know the CCG really what is important for that. So this is the main story to the hypertension. So hypertension from the beginning, I'm very interested in because I'm working for the clock gene. So, and I learned this kind of day-night rhythm in the physiology about 40 or 50 years before, or 40 years before. So it's very famous phenomenon for the rhythm of the blood pressures. And also, as you know, that non-dipper causes no night-time decrease shows high incidence of cerebral and heart strokes. And as you know, that there was an increase in daytime infarctions. So to work for this, I think for the rhythm, for making the rhythm only by the rhythm disruption, I think it's a very extreme condition I should have made. So I'm very interested in making that completely arrhythmic mice. So completely arrhythmic mice, in the usual mice, there was a rhythm like this in a content description, in a DD, constant dark conditions. And as you can see here, this mice, cry double knockout mice, have the rhythm. This is a Netherlands group work. It's very, very interesting work. And this is the first animal, they don't have the rhythms. Okay? Complete don't have the rhythms. So, behavioral occurs. So, we collaborated before their publication to Nature. They contacted me and worked with them to do such kind of work. What is the, at that time, we don't know whole cells have the body clock, but only SCN cells have the clock. So we do first the SCN rhythm is disrupted or not in the 1999, the same time of the cry knockouts are done. So usually there is a rhythm, but this mice lost the rhythm, part 1 and part 2. So central clock stops in cry neuromices. This is 1999 work. And what is happening to the others work? So in all of the cells in the cry double knockout mice, this is cry double knockout mice, and wild type mice. As you can see, there's nothing rhythm. So no cell clocks exist. No, this kind of oscillation occurs, so as it is. And also, we checked about the loss of rhythm in a fibroblasts, from the described cry neuromices. And we found that the cry double knockout mice have the rhythm, no rhythm, as you can see. So the peripheral clock stops in cry double knockout mice. So cry is totally a rhythmic animal. So I think there might have happened something about it. So we try to measure about the mouse blood pressure continuously, but it's very difficult technique for me to reproducible results. So it takes about 7 years. After 7 years, I can use that telemetry system. It's very interesting and very small for the mice. It's very nice. So we measure blood pressure of mouses. They have the very clear rhythm of the arterial blood pressure. And also, cried abdominal mice is seeing that, oh, there's no rhythm, okay, sorry, or no rhythms. But unfortunately, I think more high blood pressure or low pressure, I hope it, but it's not normal. So slightly I am disappointed. But I noticed that humans make salt have the tendency to have the hypertension. So I loaded salt to mice. But as everyone knows, that in a normal mice, it's very strong for salt loading. There's no change of their rhythmic. But cried abdominal mice is very interestingly gradually increase the blood pressure, and 40 millimeter Hg changes after 1 week. So there is a non-dipper type hypertension. Okay. So for the hypertension, it is surely the mechanism exists about surely in the ECE from the nervous root to directly regulate that autonomic center. So this will be the one root. But we should, as I talked in a previous several slides, we should not recall about the oscillation in the several bodies. The liver, kidney, this is wrong, the lung, and adrenals, blood vessels, heart, they have the rhythm, or surely have it. So I'm very interested in the renin angiotensin aldosterone system for this. This is a very big regulator. And because I believe this is important, so I want to get it from this kind of analysis. This is the renin angiotensin aldosterone. Previously, from the study, we already demonstrated that using that per look luciferase animals, when animals are exposed to the light, to the eye, one organ is very brightly light up. This is adrenal. So from the first, I'm very interested in the adrenal. So we focus on adrenal. So we first examined the plasma aldosterone in cried abdominal mice and found it's an interesting thing, very remarkably high aldosterone levels in the cried abdominal mice in spite of the wild type animals are 10 times over high. And checked about the plasma renin activity. Plasma renin activity downs. It means that there will be a primary aldosteronism. And we extracted the adrenal to the medium and measured the aldosterone levels in the medium and found that the increase. So the cause exists in the adrenal gland itself. So we performed microarray and found that one of the cried abdominal mice 6 time point, wild type 6 time point. Only cried abdominal has a big 1 point. This is HSS 3/6, as you can see. Okay. So and also we should say that the mRNA change, not only mRNA change, it reflects the protein. This is the Western blot price, very high, HSS 3/6. And enzyme activity, we measured the adrenal glomerulosa. There was a very high impression. And also, we checked about the inhibitor, tolerasterol, to the inhibition of the aldosterone secretions in the cried abdominal mice. The wild type no change, but cried abdominal. So the dose dependent. So at least in these mice, this enzyme have the rate limiting activities. So what is the mechanism? The SS3/6 is a clock control gene. So usually there is expression small, but it's a clearly clock control. And this clock control is from the D side. And for the D side, DBP to E4, BP4 plus and minus, DBP and equal BP4. In this mice, chloride development curve is always plus factor is high, without is minus factor is low. So in the accumulation, HSV6 is increased. And why it's only occurred, aldosterone is increased without affecting the corticosteroids and also the pregnenolone, because 3-beta exists is a pregnenolone, progesterone to pregnenolone. So this is a very primary stage. This should be changed. But we checked about laser microscopy to the region specifically and found that the increase occurred in the ZG cell only. So perhaps ZG, this protein may only express in the ZG. So we made antiserum to HCB36 and found that ZG is only expressed, and found the colocalization of CP11B2 completely colocalizes. So, and the next thing is we do that use an aldosterone blocker, and then we check about it. Okay. So, and when applying it, just dosed day by day, it decreases the blood pressure. So it's hypertension is caused by this effects. Okay. So then we check about humans, what is happening to humans. So the placenta skin or previous mouse have 6 genome, and human have the 6 gene, but human only 1 and 2. But others exist, but it's a pseudo gene. So we checked about what is that further 6 HSC 3-beta-6 depends on. We think previously it is known that type 2 is expressed only in adrenal. So we think perhaps type 1 maybe exists ZZ. So we checked the possibility, and we donated by the human. We can use the human adrenal in the normal. As you can see, as expected, HSS-beta-1 is expressed as ZZ, but ZF is just type 2. So it is very common. So that every HSS-beta was specifically expressed as ZZ, it's a conversion of the aldosterone secretion. So we found that ZG specific enzyme, HSV, it will be important for this kind of cell. Then what we should turn to the works of the works. So that the primary hydroxyl is a very important thing, as you can see. So the tumor, APA, and IHA exists, as you know. What is the type of chloride aminocarb? Chloride is ZG of the chloride with mice, shows the hyperplasia and the bilateral increase of aldosterone and HSD6 increase. Not only exists, the secretion of aldosterone is increased. So it may be the primary IHA's molecules. So we are strengthening that makes the HSD3-beta-1 specific antibody using the monoclonal antibody. Previous antibodies, the pan-HSD3-beta, as you can see, it's only this, they recognize 2 of them. But this enzyme only recognizes type 1 only, not type 2. We confirmed it about the histochemistry also. So we do that the human normal cortex for this. As you can see, there was a difference. Previous have both 2 layers are stayed, but now it's only ZG is staying. Okay. So this is very expected, and we hope this we can analyze about IHA for this kind of works. So I will only have a time, so I only show several data about why that oscillates, that this is adrenal cortex, as you can see. This is after the treatment of angiotensin II. So usually they have the rhythms, but the rhythm amplitude increase after the treatment of angiotensin. So I'll skip and then, and we check about angiotensin 2, the effect of the SS3 beta 1. Angiotensin 2 rapidly increases, and it AT1 receptor block it. So AT1 mediated mechanism, it helps the inductions. So I skip all of the data, but I will show the finally in this mechanism, AT1 mediated NGF1B mediated NBROE site of the HSC3 beta 1, it recognizes angiotensin 2. Okay. So the clock and angiotensin 2 binds in this site. And most CCGs are not only controlled by the clock, but also other regulators. Finally, I show one final figure about aldosterone in a B, because aldosterone is a target, kidney is a target of aldosterone. So kidney have also the rhythms, clock oscillations. And as you can see, we recently found that the kidney have the oscillation, as you can see, and the specific part of the kidney, I think it is distal nephron, have the oscillating, this ability. Okay, so thank you very much. This is the last slide of me. So rhythm exists at everywhere, every time, and we can analyze about, and it will be important for the understanding the diseases. Thank you very much.